So now we'll solve question number 12 from exercise of chapter vector from your Facebook zero field or bridge course basically. Let's read the question. According to the question, the projection of a vector R, and the R is given as 3i cap plus j cap plus 2k cap. So projection of this vector on the xy plane has magnitude, meaning they are asking about the magnitude of the projection along the xy plane because of this vector. So let's first focus on the projection first. So R vector is given as 3i cap plus j cap plus 2k cap. The question is how we create this vector. How we create this vector? To create this vector, first we take this vector 3i cap, meaning we go 3 units along the x-axis. Then we go 1 unit along the y-axis. And then we go 2 units along the z-axis. And then we get R ultimately. So when I talk about the projection of this vector along the x-axis or component of this vector, projection component, same thing actually. If I talk about the projection of this vector along the x-axis, that is 3. If I talk about projection of the same vector along the y-axis, that is 1. And projection of this vector along the z-axis, that is 3. That is 2. That is along the line. If I talk about the projection of this vector in the xy plane and projection in terms of vector, the projection vector of this in the xy plane will be 3i cap plus j cap, because that's how you are creating it. So in the xy plane, you went 3 and 1. Then you went to z-axis. The same vector you can create by first going z-axis and then y-axis and then x-axis as well. If I calculate the projection of this vector in the y plane, so this is y and this is z, so this is going to be the projection. If I talk about the projection of the same vector in the xz plane, then it will be 3i cap plus 2k cap, projection vector. But since they're asking about the xy plane, so first let me calculate the projected vector. The projected vector along the xy plane will be 3i cap plus j cap. But they're not asking about the projected vector. They're asking about the magnitude of this vector. And how do we calculate the magnitude of this? Pretty simple. Magnitude basically is under root of x component, which is x component square, which is 3, plus y component square, which is 1 square. There is no z component. So this will be under root of 10. 9 plus 1. So the projection of this vector, the magnitude of projection of this vector in the xy plane is coming out to be under root 10, which is the fourth option. As you can see, that is given under root 10. So that is your answer. So in this question, we learn from a 3D vector how to get the projection. We can get the projection along the individual directions. We can get the projection in the individual planes. And we can get the vector projection in the 3D. That's the projection basically, any plane we want. Okay. Thank you.